Now we're going to determine a way to find how big each angle is in a regular polygon, and we can do that just knowing the number of sides. We don't have to know how big the sides are, just how many of them, if it's a regular polygon. So we're going to use the property that regular polygons have congruent interior angles. All the angles are the same size. And here I'll show you the proof for the formula. First of all, I'm going to tell you I have a polygon with n sides. Each interior angle has measure A. And we're going to develop the formula that the measure of those angles is just 180 times n minus 2 divided by n. First of all, on my first statement on my proof, I said each interior angle measures A. Well, that's given. And I could also say that's the definition of a regular polygon. Now, if I try to add all those angles together, I know they're all A. So I can go A plus A plus A. Well, if there are n of them, the shortcut is just n times A. So, you know, that's the definition of a sum. I can shorten it to multiplication, where it's A times n. I also know that the sum of the angles is 180 times n minus 2, because that's from the polygon angle sum theorem. All polygons, I just say 180 times n minus 2, whether it's regular or not. Now I'm going to put these two pieces together by substitution, and I create my equation. Then I can say, okay, I've almost figured out how big my angle is, but that n's there, so I'm going to divide both sides by that n using the division property of equality, and I get my formula, which is the measure of any angle is 180 times n minus 2, all divided by n. So basically it's saying find the total number of degrees in an angle and divide by how many angles there are. So in this example, we're going to find the measure of an interior angle of a regular dodecagon. Dodecagons have 12 sides. So I'll write down the formula. The angle is 180 times n minus 2 all over n. So it's the total number of degrees over the number of sides. Basically, 12 minus 2 is 10. Do the multiplication and divide by 12, and I get 150 degrees. For this next example, I'm going to tell you how big an angle is, and you're going to tell me which polygon it is. How many sides does it have? So we're going to use the same formula. The angle equals 180 times n minus 2 all over n. So it's important to use the left side of the formula. A lot of you just want to use this right side. You have to use both sides. So I substituted 165 in for A, and now I'm going to solve for n. First, I'm going to multiply both sides by n using the multiplication property of equality. And you can see these two n's will simplify. So I can actually cancel them out, or they simplify to 1. So here we go. Then I have 165 times n, and I use a distributive property, and I get 180n minus 360. All right. Subtract 180n from both sides, and I get negative 15n equals negative 360. Finally, divide both sides by negative 15, and I get n is 24. So my polygon has 24 sides. It's a 24gon. So for further reflection, does this formula work for any polygon? Why or why not? And how do we use the properties of regular polygons to determine their interior angles?